It takes 4 minutes to get from Earth to Mars. According to scientists and new satellites, Elon Musk and other pioneers are dreaming of a future that may soon come true because international researchers are probably about to make a breakthrough in their quest for faster-than-light travel. Before we begin, we would like to ask for your support. You can easily do this by subscribing to our channel, turning on the notification bell, and leaving us a like at the end of the video. The news has been coming in over the past few months and years, and today we'll look at what's actually happening, with warp drive and the like. Oh, music. We know that light is a mission of the stars in the universe. It is quasi-created as a byproduct of the stellar fusion processes. Light spreads out in tiny waves faster than light and at breakneck speed. For example, if you turn on a light bulb in your home, the entire room is suddenly lit up. The time it takes for the light to reach full illumination is less than a fraction of a microsecond, so you can't notice it consciously. Quanta are the fundamental units of substance and also minuscule particles of light. According to quantum physicists, light is one of the primary information carriers in the universe. Albert Einstein discovered just a century ago that light, or its speed, is the only quantity in the universe. Light travels through a vacuum at a speed of roughly 186 to 182 feet per second, which is a constant force in the universe rather than a relative one. The light year, which measures the distance that light may travel in the universe in a year, is another cosmic unit of measurement for light. It is approximately 6.2 billion miles. Astronomers and physicists use the light year as a unit of measurement to measure and characterize the vast distances in our universe. Depending on the current positions of Earth and Mars, it would take 5 months to 2 years for humans to travel to Mars. If humans wanted to travel to the end of the solar system under the current conditions, it would take more than 100 years. The relatively small Voyager probe would take 33 years to reach the nearest Alpha Centauri star system, which is 4.3 light-years away, while a large spacecraft would take several thousand years. If we consider these distances realistically, we must acknowledge that humans still have some work to do if we wish to travel through space or even within our own solar system. Since NASA sent humans to the moon in the 1960s and 1980s, the dream of manned space travel has essentially never materialized. Although humans currently reside in space aboard the International Space Station, ISS, which is located near Earth, we have not traveled farther than the moon, and that was 40 years ago. The new space pioneers and NASA. In the near future, Elon Musk's SpaceX and Jeff Bezos's Blue Origin space launch firm hope to take people into space once more. They are planning manned trips to the moon. The main issue with these expeditions is that SpaceX even plans to send the first scientists to Mars beginning in the 2030s. Astronauts are currently only permitted to remain on the ISS for 6 months, due to the length of time and stress that space travel places on the human body. After that, they risk issues like eye impairment, muscle atrophy, and an elevated risk of cancer due to high cosmic radiation levels. Before humans reach the point where they can fly at superluminal speeds through manipulations of space-time, we'll need spaceships that are 2 or 3 times faster than the current ones, which would require a huge technological leap. Spacecraft. Traveling close to the speed of light could cut the travel time from Earth to Mars to a few minutes. Traveling in a warp bubble would also largely spare humans from cosmic rays and other harmful effects of interstellar spaceflight. Elon Musk is the first person to propose sending humans to Mars. Although plans for a Mars colony and announcements of Mars missions have been around for years, physicists and astronomers still doubt that such projects will be practically possible, until 2019, when faster spaceships become available. Neil deGrasse Tyson, a U.S. astrophysicist, challenged the CEO of SpaceX and Tesla on Twitter, advising the multi-billionaire to stop investing time and resources in Mars rockets or Cybertrucks, and instead consider creating a warp drive. Back in the early 1990s, physicists were testing the idea. At first, the prospects were bleak, but as early as 1994, a Mexican researcher presented a calculation that clarified what Musk meant when he said that his planned city on Mars would be the powerful driving force to invent warp drive. To this day, no one knows whether SpaceX is working with international scientists and developing warp drive or not, and how realistic is the warp drive. As a brief reminder, warp drive propels spaceships through space by compressing space in front of the vehicle and expanding it behind it. This creates manipulation folds in the space-time fabric that allow for the quick covering of greater distances. This makes the fantastic drive actually possible. The only issue with Alcubierre's solution was the comparatively high amount of energy required to manipulate space-time. Without massive reactors on board, his speech ship would not have been able to take off any faster than it did today. However, a solution was quickly found to this issue as well. In 2010, American researcher Dr. Harold G. Sonny White discovered a type of propulsion that requires no fuel or energy at all, and only so-called negative or exotic energy. Miguel Alcubierre was the first to demonstrate in 1994 that propulsion did not violate Einstein's laws. The new issue that emerged was that, although the existence of negative matter had not been established in 2010, White was able to show in 2021 that there was some negative matter present in the Casimir effect. At this point, it is insufficient to power a spaceship that weighs tons, but the technology may hold promise for the future. Before the presence of negative matter could be established, researchers mainly set out to create models of extremely rapid motion that don't require energy. This was accomplished with the invention of the warp drive and the microwave drive, which allowed for flight at the speed of light. A British scientist named Roger Scheuer, a former project manager for the Astrium space business, came up with the most intriguing idea. He created a hypothetical microwave drive that might compete with warp drives. Theoretically, Scheuer's EM drive creates thrust by bouncing microwaves off a copper cone. It is based on Newton's second law, which states that force is the rate of change of momentum. An electromagnetic wave traveling at the speed of light has a certain momentum that, when transferred to a reflector, results in a tiny force that, when accumulated appropriately, could become so great that even without any propellant, the EM drive could still reach the speed of light. NASA declared that tests using an engine based on EM technology have repeatedly been successful. Shortly afterwards, a scientific group from China announced that it had also successfully tested this engine tested in Dresden and found to be unsuitable. Critical scientists did not readily believe the results of NASA, and the Chinese ideas about microwaves generating thrusts sounded too unreal, and some German physicists raised questions such as how these waves should be initiated, how they should move, and where they should get their momentum. Consequently, they were put to the test. The test took place at the Technical University of Dresden in Dresden. They came to quite different results, and the researchers told NASA and their Chinese colleagues that something could not have been quite right with their test series, because in Dresden the EM drive failed, despite several attempts since NASA did not comment further on these criticisms, and no statement could be heard from China either. All hopes have turned back to the warped drive. After all, once implemented, it could solve almost all the problems of manned spaceflight in one fell swoop in an artificially generated warp bubble. It's not the spaceship that moves, but the universe, so to speak. In the best case, the occupants of a warped spacecraft would not notice much of their interstellar journey. Will Dr. Eric Lentz bring us warp drive when Captain Picard was jetting through space and time on the Enterprise physicist Eric? Lentz, now 34, was still a young boy. Even then, Lentz couldn't stop wondering whether warp drive was realistically possible during the pandemic. Due to a unique situation in the geometry of space-time lens, Lentz, who had nearly lost his job, looked again at the Alcubierre drive and Dr. White's improvement out of boredom. He found solutions for the drive that didn't require the use of exotic or negative energy at all. He found the solution in Einstein's field equations. These allow one to compute the ways in which specific matter and energy distributions distort space-time, such as the way the Alcubierre lens breaks space-time into stacked layers. Only the practical astrophysicist Lens looked for and discovered far more complex units than the theoretical physicist Alcubierre. Although the model does not realistically surpass the speed of light, the concept of super-fast propulsion without fuel was first presented by the Swiss research group Applied Physics. The concept of Lenz's draft allows for the use of a large quantity of energy because it consistently uses positive forces whose existence is already known and confirmed. In a few years, spaceflight will have advanced significantly. We are still interested in the innovations that we might soon be able to share here, and we naturally hope you will be present. Please share your thoughts in the comments section below. We hope to see you again soon. What do you think about the future of manned spaceflight and the development of a faster-than-light drive? Do you think warp drive will be feasible soon?